I'm very much happy to begin a journey and just get to look at the principle of mathematical induction. So I've got up to 9 questions that we'd have to look at, and then from 6 we have more advanced questions where I would have to prove that 2 raised to the power n is basically greater than 2 multiplied by n for positive integers greater than 2. And then we also need to prove that n to the power 3 minus n is divisible by 6 for all positive integers. We need to prove that 2 to the power n plus 2 plus 3 to 2n plus 1 is divisible by 7. And then we need to prove that as well. So basically, the principle of mathematical induction helps us to prove for all numbers, okay? So it's like for this question where they want us to prove that it's basically for all positive integers. What that means is no matter what integer you get to put positive integer from 1, let's say all the way up to 1000, still going up, it will still be true. So you can prove, of course, by using first two numbers and all, but you need to prove that it's okay, it will still be true for any number that can be used. Okay, so let's try to understand this equation that we have. So what do we have? So this formula is basically the formula for the sum of n numbers. Okay, so when proving using mathematical induction, we have to using what we call the base case and the inductive hypothesis. So to just help you understand, let's try to add the first 3 numbers. So if you add the first 3 numbers, 3 plus 2 plus 1, that's 6. Now, is it true that if you substitute in that formula, you just say, okay, 3 plus 1, because then you're representing the number of the first numbers that you've added in the series. So 3 plus 1 in the brackets will be a 4 times 3, 12 over 2, which is also a 6. Okay, so you've seen that it is true, right? Now, you can't try all the numbers, so you have to prove like that is going to like agree for any numbers that you get to add. If you add from 1 all the way up to 100, if you plug in that formula, you still get the same answer, or add them manually, you still get the same answer. So how do we do that? This is where this formula now comes in, the principle comes in. Okay, so each time we are using this, we need to always come up with a base case. So in most of the cases, the base case, we use the first one. Okay, so in this case, we're going to use n is equal to 1. That means the sum of the first 1 numbers, but it doesn't make sense, so let me use for n is equal to 2. That means the sum of the first 2 numbers. So that means 1 plus 2 on the left hand side. So let this be the principle of n, right? Okay, so 1 plus 2 is basically equal to, so we've gotten the first 2 numbers. Now, is it true that if you use the formula, you still get the same answer? So put 2 plus 1, because the n on the right hand side is presenting the how many numbers you've added in the series. Okay, so we've added the first 2 numbers. So you've got a 3, then this side, the 2 outside will divide by that 2, which will also still give us a 3. So for our base case, that is true. So after base case, now you come up with what you call now the inductive hypothesis. Okay, the inductive hypothesis. So this inductive step is where now we'll say we'll assume, first of all, what are we going to assume? So assume n is equal to k. So what our equation becomes, so assume n is equal to k, then, so if you go back to our formula there, the formula itself says 1 plus 2 plus 3. As you add any numbers in that series, it should be able to give you. So now where there's n, I'm supposed to put k. Okay, so put k equal to k plus 1. What I've done is where there's n, I've put what? K. So then we can say then if so the inductive hypothesis implies that if this is true, therefore we should also have a case where if our next term was going to be k plus 1. Okay, so I can erase this. So I'll continue for our inductive hypothesis. Therefore, if we are to add the numbers from 1, 2, all the way up to k itself, but we're not ending at k, so we'll still add an extra number. That means if we add k plus 1, k plus 1 is obviously the next number after k. It should also stick. So the idea, if you look at the formula, is if you add the numbers from 1 all the way up to n itself, that means if you're adding the first 10 numbers, you add from 1 all the way up to 10. If you're adding the first 4 numbers, 1 up to 4. So if you're adding the numbers from 1 all the way up to k plus 1, your n there should be k plus 1, because if you're adding up to 4, your n will be 4. So if you're adding from 1 to k plus 1, the other side, your n will be also k plus 1, because that's where you're ending. There we'll have k plus 1. Now in addition to k plus 1, we also have another one there. So plus 1 over 2. Now of course, the other part can just reduce, part can just simplify to k plus 2. So this is what we need to prove now. Okay, so the inductive hypothesis implies just let n be equal to k, and then if this is basically true, we need to show that this is also true. So if we can prove that the left hand side is equal to the right hand side, then we are good to go. So that's basically what we need to do for mathematical induction. So let's prove. So I'll say, let me call that pk plus 1, and then we'll call this k, p of k. So what are we saying? So the left hand side, so you can see that the right hand side is already simplified. So let's look at the left hand side. So left hand side is equal to, so we have 1, adding numbers from 1 all the way up to the number itself, the first numbers that we want to add. So we're adding all the way up to k plus 1. Now you already know from the inductive hypothesis to say 1 all the way up to k is equal to that. So 1 all the way up to k is equal to that. So substitute. So k plus 1 over what? Over 2. So that is including this part, 1 all the way up to k. Okay? Plus, we are still remaining with a k plus 1 there. So if this can simplify to the right hand side, then we are good. So this is equal to, common denominator there is a 2. So we have k plus 1. After dividing into 2, the other side will also be multiplied by the 2. So all over 2. That's basic division. Okay? Are we any closer to the solution we have on the other side? Okay, we're getting there. So if you try to observe here, k plus 1 is common. So if you factorize it out, you remain with k plus 1 and then k plus 2. I'm sure you've ever done the factorization of quadratic functions. So since the left hand side is now equal to the right hand side, hence proven. So we've now proven. So just to summarize whatever we've talked about here. So the basic idea is, in simpler terms, forgetting about everything that I gave you, the first part is you need to come up with a base case where you get, for example, the first two numbers, 1 plus 2. If I put 2 there, I will get the same, the left hand side will be equal to the right hand side. Now, for the inductive hypothesis, you just let where there's your n, you put a k there. And then you say, if that is true, then even if I add a new term, k plus 1, the left hand side will still be equal to the right hand side, which we've proven now. Okay. So if you've understood what we've done from previously, you can basically try everything out. This example now, I'm going to be a bit straightforward since we know now what we're talking about. Okay. 1 plus 2 plus 2 squared plus that is equal to that. What does this mean? We need to prove that for all positive integers, this is going to be true. What does this mean? So what this means is, if you add the numbers in this series from 1 all the way up to 2n minus 1, it should be equal to that. An example is if I add from 1 to 2 all the way up to 2 to the power 2. Now, taking this to be equal to n minus 1, it means that the value that I've added here is I've dealt with the first 3 things. So first 3. So for the first 3, I expect that it should be equal to what is on the other side. So the summation of the first 3 terms in this expansion should be equal to that, by just substituting the 3, representing how many you've added. Let's try if it's true. So I've got 3 plus 2 squared is 4. Then there you have what? 8 minus 1, which is also 7. So that is already true. So let's try to prove now by PMI, Principle of Mathematical Induction. So we'll say we need to come up with a base case. So of course, let's take the entire equation to be just the p of n. So for our base case, we use the value of n to be equal to, let's take the first 2 again. So n is equal to 2. So for such a case, we are saying for the first 2 terms of the series on the left, it should be equal to 2. How many numbers have we added? 2. So the number on the right hand side, so what appears on the right hand side is more like a formula that you can just use to get the summation of the first n terms in the expansion. So instead of doing it manually, we are saying you can use that formula. So we are trying to come up with a base case where we are trying to, you can't just make a point from without. You need to at least try out something and say, this is working. So after you say that this is working, you need also to prove that it is working for all other series as well. So for the first 2 terms, if I add 1 plus 2, it should be equal to just substituting the formula, the first 2 things that I've added. So we've got 3, and then 2 squared is also 4 minus 1, which is 3. So this is true. So we've got our base case. Now we'll quickly go to the inductive hypothesis. So for the inductive hypothesis, we'll say let n be equal to k. So if that is the case, then we'll just go back to our formula, and then where there's n, we'll just put our k. So it will be k minus 1 equal to 2 to the power k minus 1. So if that is true, therefore, or then, so if that is true, then even if we introduce a new term after k minus 1, so if you add k minus 1, so this is of course for p of k. Now if you deal with k plus 1, what you basically do is where there is k, we'll put k plus 1 for the next term. So it will be k, so it will be 2 the power k plus 1. Now don't forget we are subtracting a 1. So in other terms, you can think of it as this way. It's more like you're just adding a 1 to the initial k that you had. So what I'm trying to say is if we add k, if we add 2 to the power k, the next term would be 2 to the power k plus 1. Now since we have k minus 1, it is to be less than the next term. So 2k plus 1 minus the 1 will get what? Just k. If you add indeed the 1 to k minus 1, you just get what? You just get a k. So equal to, now where there is k on the other side, we should add k plus 1 terms. Okay. I hope that is clear. So what I've said is, we are just adding a 1 to the previous term, to the previous term's power, because that's what we've observed actually. If you check, we started 2 to the power 1, 2 to the power 2. Okay? So if you have k minus 1, the next term is going to be k. But on the right hand side, we have added up to k plus 1 terms, right? And that is true. If you check there, n minus 1 is less by a 1 compared to n. So even in this case, k is less than by a 1 to k plus 1. So hopefully that is okay. So that is just basic mathematics. Your work now is to prove that it is going to be true. So let's prove the inductive hypothesis that we've come up with. So we have 1 plus 2 plus 2 squared plus 2k minus 1 plus 2 to the power k should be equal to 2 to the power k plus 1 minus 1. How do we prove all this? So focusing on the left hand side, which is equal to 1 plus 2 plus 2 squared plus 2 to the power k minus 1 plus 2 to the power k. So from the inductive hypothesis, we already know that summation of numbers from the first one n up to, how have I forgotten that there's, okay, yeah, all the way up to this part, that is equal to what? That is equal to 2k minus. So we can substitute, because this is what we are seeing. This part is equal to that. So we'll say that is equal to 2 to the power k minus 1 plus the 2k there. So we need to prove that is going to be equal to what is on the right hand side. Now look at the right hand side. We've got 2 to the power k plus 1 minus a 1. So we can collect the like terms. So we've got 2k, and then we've got also another 2 to the power k. So 2 to the power k minus a 1. Now adding these, since they've got the same power, they are like terms. So that means that is equal to 2k. What that means is the 2 to the power k is taken as a variable and not as a number. So it's like if you have got x plus x, it becomes 2x. Now your x is 2 to the power k. Okay, so it now becomes a product of 2 to the power 1 and 2 to the power k, which is of course minus 1. Now that is going to be multiplying numbers with the same bases, add the powers. So it is k plus 1 and then minus a 1. So at that point, you can now see that your left hand side is equal to the right hand side, hence proven. Left hand side is equal to right hand side. So hence proven. So you come up with a best case inductive hypothesis and then after you introduce a new term of k plus 1, it should still be true. Okay, from what we've talked about so far, how confident are you? Are you able to pause the video and try out this one? Okay, we can now continue. Are you enjoying this video lesson? So you can actually access the entire topic you are watching or the entire practice questions of a video that you may be watching right now. So if you go to our website is transcendedinstitute.net. Okay, so there are three ways that you can access our videos. So you can use Patreon, you can use channel memberships. If you're in a country where it's allowed, you'll be able to access our full topic videos and full practice questions. So alternatively, you can access the videos using our learning portal. The link is learn.transcendedinstitute.net. So I'll show you a few videos that you can have access to after registering. So for example, if you had to open mathematics as at now, these topics are the ones that are available, which you can learn from scratch. I can just give you an idea of, so you like learn everything from scratch, meaning that even if you're learning something for the first time, these videos are there to help you with concepts as well as practice questions. So for example, these are tutorial sheet solutions from different tutorial sheets, which can help you as well get to learn faster and remember. So binomial as well, there it is. And of course, this applies to all these other topics that are available: trigonometry as well, calculus, depending on the topic that you're interested in mathematics. So you can just head over to the site at now to check what is currently available. Even without registering, you should be able to see the content in each topic. So let's assume you're interested in physics. These are the topics available as at now. So if you open chemistry, these are the topics available as at now: electrochemistry, stoichiometry, thermochemistry, kinetics, equilibrium, solubility, equilibrium, atomic structure. So trust me, if you open these videos, you might have learned the topic in full. Let me show you stoichiometry. So stoichiometry, we have all the way up to 21 videos, including the tutorial sheet solutions, which will help you to practice both the concepts and also prepare for questions. Okay, so feel free to head over to the site and check out these videos on your own. So equally, biology videos are also available, which you can also basically get to access. So these are the topics available so far. Yeah, so pretty much these are the ways you can easily access our full membership videos that you don't have access to on the channel. So I believe you are now able to interpret what this means. So again, this is a series. So what we are trying to say is the summation of the first numbers n numbers is going to be equal to what? What are we saying? So if we add numbers, this last part is very important. The last part is very, very important, to the power n. So what that means is if you're adding the first n numbers, you n to the power n. What am I saying? So if you're adding the first three terms, for example, so you say 1 plus 2 plus 2 squared. If you n there, then you're dealing with n is equal to 2. But if you are trying to add up to 3, then you say you end at 2 to the power 2 to the power 3. Okay? So what does that mean? That means that it is still going to be equal to 2 to the power 3 plus 1 minus a 1. That's what it means. Okay? So we need to prove that this formula is going to be true for any cases. If you add 1 all the way up to 2 to that power, it should be equal to 2 to that power plus 1 minus 1. Okay, let's come up with a base case. So for our base case, we have what? Let our n be equal to up to the first two numbers. Not necessarily the first two numbers, up to the power of n is equal to 2. So that means we have 1 plus 2 plus 2 to the power 2. according to the formula, what is the last part? If you are saying n is equal to 2, then you are ending with 2 to the power 2. I hope that is clear. So we need to prove that is going to be equal to what? That is still going to be equal to, the formula there is, since our n is equal to 2, we'll say 2 plus 1 minus 1. So 2 squared is 4 plus 3, 7. 2 to the power 3, that is 8 minus 1, 7. So our base case is there. We've already come up with a base case. So base case is giving you a starting point. So after you've shown your base case, you can now go to the inductive hypothesis. So let our n be equal to k. So if that's the case, if 1 plus 2 squared plus all the way up to 2 to the power n, it should now n is equal to k. So wherever is n, we're putting k now. Okay, so if that is the case, then we should expect that therefore if we introduce a new term, so the new term is going to be what? It's going to be 2 to the power k plus 1, right? So 1 plus 2 squared plus 2k to the power k. So now we're now introducing a new term which should be to the power k plus 1. Wherever is k, we are putting k plus 1. So even if we do the same on the right hand side, so wherever is k, we're going to put k plus 1. So k plus 1. But don't forget that there's also there's a 1 already there. So it will be plus 1, which will give us a 2 now, minus 1. So we need to prove that the left hand side is equal to the right hand side. So for our left hand side, we have 1 plus 2. So I know now you're smart enough, you are able to follow up. So this is the left hand side. Now for the left hand side, I'll go directly. Since from the inductive hypothesis, you're able to tell that this first part is equal to that, right? Check, you can check this part, it is equal to that. So therefore we'll substitute 2 to the power k plus 1 minus 1. Now don't forget there's a new term which is remaining there. So plus 2 to the power k plus 1. Now we need to prove that this is going to be equal to what is on the right hand side. So again, we can see that we've got like terms. These are like terms. If we add them, we'll have a 2 of them. So 2 times 2k plus 1. We've added them, taking them as a variable x. So 2x. So now if you've got the same base, you can add the powers. So 2 to the power 1 plus k plus 1 is going to be 2k plus 1 plus 1. So which is going to be plus 2. So now your left hand side is equal to the right hand side. So we're good to go. We've got question 4. 1 squared plus 2 squared plus 3 squared plus that plus n squared is equal to that. Now, I said it's very important that you try to observe the trend of a formula. If you look at this formula, what we are noticing is we are just adding like numbers all raised to the power 2. Okay? All raised to the power 2. All raised to the power 2. Now your n is a base. So if you say add the first 3 terms, you add 1 to the power 3, they should all be raised to the power 2. So adding these numbers is as good as just putting a 3 there. That's what we're trying to say. Wherever is n. So for our base case, you don't want to complicate lives. So say, so I want to help you be very much smart. So for a base case, if you can see that on the right is too big, just try to be as simple. Just say, let's take our n to be equal to 1 so that you don't go anywhere. meaning that for the sum of the first n terms, of course I say it doesn't make sense, but it does. So say where for n is equal to 1, meaning that you're just ending with 1 itself, so 1 squared. On the other part where there's n, you just put 1's, so 2n, which is also 2 over 6. So you have 1 is equal to, so 3 multiplied by 2, that is going to be 6, so you have a 1. So that is our base case. So since we've got a base case proving that it is true, at least for a single term that we know of, let's now try to prove. So let's come up with the inductive hypothesis. So of course, letting our n to be equal to k, we are saying if 1 squared plus 2 squared plus 3 squared plus k to the power 2 is equal to k plus 1, 2k plus 1 over what? Over 6. Now, what do we do now at this point? So therefore what? So therefore we need to introduce a new term. So I have 1 squared plus 2 squared plus 3 squared plus k squared. Now we are now introducing a new term. So where there is k, we'll put now k plus 1. So it will be k plus 1 squared. So where there is k again on the right hand side, we'd have to put k plus 1. So now at that point where we've got k plus 1, if you put a k plus 1, k plus 1. So k plus 1 would be now k plus 2. Again, where we've got a k again, we'll put 2k plus 1. We'll put k plus 1, sorry. So if you put k plus 1, you multiply 2 times k, it will be 2k. And then you multiply by that other one, it will be a 2 plus a 1, it will be a 3 over 6. So there we are now. Now, don't forget again, we can now prove that our left hand side is basically going to be equal to our right hand side, right? So for left hand side, as a good student, first of all, write that, but I'm not going to write it. And then on the next step now, you can show that 1 all the way up to k squared, that part is equal to what? So you have k plus 1, 2k plus 1 over 6. Now don't forget that there's also this part which is independent of that. So plus k plus 1 squared. That is for the left hand side. Now we need to prove that it's going to be equal to the right hand side. Okay? So being smart about it is trying to compare it with the right hand side. So far I can see that k plus 1 is common. So what I'll do is I'll factorize k plus 1 since it's common. Okay? I'll factorize it. I can see that it's common. Now before that, I can actually balance things up by having 6 as a common denominator. So if I do have got 6 as a common denominator, it would mean that the other part which is not having 6 will have a 6, and then it will be multiplied by a 6. That is basic addition. Common denominator, divide the 1 into a 6, it will be 6 here. So it's like we just have a common denominator of a 6, and then that part should be multiplied by a 6. Okay, so hopefully you've gotten that. If you've not, just do it normally and just introduce k plus 1 squared over 1, divide that 1 into a 6, which is still going to go back there. I believe you've gotten it. So let's factorize the k plus 1, which we can already see that it's common there. So if we do factorize the k plus 1, what is remaining for the first part will remain with what? So I'll put the square brackets. We're remaining with a k and 2k plus 1. Then the other part, since k plus 1, the power 2 means is as good as saying k plus 1 and again k plus 1. So we factorized out 1. So we are now remaining with 6k plus 1. Okay. Over what? this entire part is being divided by 6. So our goal is to simplify it and make it equal to the right hand side. So at this point, it is not necessary even to have the question itself, because all we are trying to prove is the left hand side should be equal to the right hand side. So anything that you can think of that we can do basically to simplify the work there. So let's try to expand it a bit. So we have k plus 1. So I'll distribute the k there. So if you multiply the k with what is inside, you have got 2k squared plus k. And then if I multiply the 6 with the other part, we have 6k plus 6 over what? Or over 6. Now, what can we do there? So be smart about it. K plus 6k, that is going to be 7k. Are we able to factorize what is on the right hand side? So think about it. If you multiply 2 times 6 as our product, that is 12. Our sum is the middle part. So what two numbers can you multiply to give you 12? You add them, they give you 7. So 3 and 4, right? So k plus 1. So let's try to factorize using 3 and so we have a 7k. Now we substitute the sum, which we've said the numbers are 4k and 3k. They are the ones you can add to give you 12k squared and then add them to give you 7, which was there. Okay. So at that point you can now begin to factorize. So if you factorize what we have, you're going to have 2k for the first part being factorized for the first two part, and then you remain with a k and then a 4. Is it a 4? No, a 2, because the 2 is pulling out the 4. And then plus the other part, you factorize a 1 and then you remain with no, we have to factorize what? A 3. So if you factorize a 3, you remain with a k plus 2. So if you group them, you have k plus 2 and then you have 2k plus 3. Okay, so we now have k plus 2, 2k plus 3 after factorization over what? 6. Now at that point you can see that your left hand side is equal to right hand side. Hence proven. You can see that that is true, right? So basic mathematical operations techniques have been used. Okay, so we're on this one. So feel free to pause the video and just try this one out before we move on to other questions.